Hi, Matt. So here is the vector field you asked about with the point that you asked about, this point 2, 1. So to make sure we understand what the question is asking, let me just say that you can always interpret a vector field as fluid flow or air flow or something like that. So let's say that this vector field represents the flow of the surface of a river or something, and you come along and you drop a tiny little leaf into the river at this point. The question is, zero point 0.1 seconds after you drop that leaf, where will it be? That's the question. So clearly, if you drop the leaf in here and the arrows are all pointing up and to the right, the leaf will move up and to the right. So your final answer should be up and to the right. And in particular, if you look at the back of the book, which I'm sure you did, here's the correct answer, 2.04, 1.03, which is indeed up and to the right. The question is, though, how does the book get this precision in their answer, this 0.04 and this 0.03 here? And the answer is, suppose you take this point and plug it into this vector field so that we can get the actual vector that's sitting at this point. Well, you plug in 2 for x and 1 for y, so you get the vector 2, 3, right? So 2 squared and then 2 plus 1 squared, so 2, 3. Okay, so the velocity of the water at this point is 2, 3. So what you would expect to happen is after 1 second of time, not 0.1 seconds, but after a single second of time, you would expect to be able to add that velocity vector to this position and get an approximate new position. So just like in Calc 1, you know how like tangent lines will approximate the original curve, and the closer to the original point you are, the better the approximation is. Well, tangent lines, slopes of them anyway, can be thought of as velocities. So the same sort of thing is happening here. Your velocity vector will approximate where you are after a second. It might not give you exactly where you are, but if you're sitting right here, you should expect after 1 second you've taken, 4 steps over and 3 steps up, right? 2, 1. So 4 over and 3 up would be your new position after a second. So maybe you can start to see where this 4 and 3 come from. Okay, so, and I guess the question you asked, sorry, this is sort of sloppy here, but oh yeah. So after 0.01 seconds, okay. So when you plug just the point into this vector, you are literally approximating where you are 1 second from now. So if you want to know where you are 0.01 seconds from now, just take that approximation and scale it by 0.01. So as I just said a second ago, you're expecting to take 3 steps over and 4 over 3 up after a second. So after 0.01 seconds, you're expecting to do 0.04 over and 0.03 up, resulting in this correct answer here, 0.04 over, 0.03 up. Okay, so the answer to your question in general is just that velocity vectors are trying to approximate where you are essentially after 1 second, but after like 1 step in time. Just like in Calc 1, the tangent line and its slopes are trying to approximate where the curve will be after 1 x step. It's the exact same idea here. So after 1 step, we expect to have traveled approximately the velocity vector, which is 4 over 3 up. So we take that 1 second, scale by 0.01, and get the answer in the back. So please let me know if you have any more questions on this.